Okay, let's go to this particular problem once again for epicyclic gear trains. You can see the diagram has been given to us, and the gears, even though they seem to be pretty much distant, we have to assume that they are meshing with each other properly. And the arm is carrying the three identical planet gears. In this case, they have been named as P. You can see here the central gear is named as sun gear, yes, and the outer one, I don't know why it's called as F. Of course, this one is called arm A. So all these three sides, they're called as arm A. They rotate together. So just like in the previous cases, we'll have to proceed by we'll have to start by drawing the table for these. So of course, every time we'll have to start with the arm, and then followed by the sun gear, yes, in this case, and then we'll have to follow it with the gear which is meshing with yes. In this case, planet P is meshing with it, so NP will have to take next, and then P is meshing with F. So finally, we'll have to take up the F gear. So as were the steps, the same steps we'll have to follow. We'll have to assume the arm is at rest, 0. So, and we'll have to give one rotation in clockwise direction to the sun gear and find out how the rotations are going to affect the other gears. So the planet gear is going to rotate depending on the number of teeth. So the relation we'll have to use here is N P by N S. So that's equal to minus of TS by TP. So the speed is inversely proportional to number of teeth, so this becomes the equation. And because we are assuming the NS, number of rotations on S, to be 1, this becomes 1, and NP becomes equal to minus TS upon TP. Then similarly, we'll have to find the speed of F, so, or the number of rotations for F. So we'll have to write the relation NF by, now NF is meshing with NP, and because these gears are meshing externally, their directions of rotations are going to be same. So we are not going to take minus sign. Minus sign we took here because, at this intersection, the rotation direction is going to be opposite for externally meshing gears. That's why we got minus here. Whereas here for these two gears, they're meshing internally, and hence we'll not have any negative sign. So NF by NP will be equal to TP by TF. Once again, we'll have to transfer NP to the other side. We get NF equals minus TS by TP. So I've directly substituted the value of NP here, and then we'll have to multiply with whatever remains here, so TP by TF. So TP will cancel out, and we'll be left with minus TS by TF. So this is what happens. So if arm is kept stationary, one rotation is given to sun gear, NP is going to rotate, the planet is going to rotate by this much fraction in opposite direction, and so it goes with NF, it will rotate by this much fraction, again in our direction opposite to the direction of yes. Okay, going ahead, the second step is we're going to give X number of rotations to sun. We'll give X number of rotations to sun instead of just 1. So we'll have to go ahead and take X here, multiply X throughout actually. So this also gets multiplied with X, and so does this one. Next, what we'll do is we'll give Y number of rotations to the arm itself. So when the arm is rotated, all the gears are situated on the arm itself. So all the gears will also rotate by the same amount. So Y number of rotations are given to arm. So this will also rotate by additional Y rotations. So the equation becomes X plus Y. Same happens here. So because X is already negative, I'll just write Y in ahead of this. So the equation, looks good. Same here, Y minus X times TS by TF. So now we know the relation between number of rotations on all the parts that are present in the epicyclic gear train. So almost every problem that you solve on epicyclic gear train, this table here is a must. Fine, you have to draw this table. Without this table, you will not be able to solve any problem of this type. Now let us proceed to see what are the given conditions, and based on that what we have to find. So in the beginning here we have been told that the sun gear rotates 500 rpm. So Ns is 500. Now it's not telling anything about rotational being clockwise or anti-clockwise. So we'll just assume it is clockwise, and we'll take the sign as plus. And we can read further here. It says the planet carrier, not the planet itself. So the arm is rotating 100 rpm in the same direction. So the speed of arm we have to take. So speed of arm. So speed of arm is written as a here. So I'll just write NA. That is 100 rpm. Now it's telling in the same direction. Now because we assumed this to be clockwise, we'll have to assume this as well to be clockwise, and for both we have to take positive sign. Now it's asking us to determine something. So we have to find the number of teeth on each gear. So all the gears we'll have to find out number of teeth. So we'll have to find number of teeth on the sun, we'll have to find number of teeth on the planet, and the number of teeth on the outer annular ring, F. And he also wants us to find the speed of the planet gear P. So NP is also something he wants us to find. So all these are the things he is asking us to find. And after asking us to find a lot of things, he is again coming to some given data. So he is giving us the module of the gear. So let us write down the module of the gears. For all the gears, module is going to remain the same. And the diameter of the fixed gear F. The fixed gear F, diameter of F is providing us, that is 300 mm. And within this one sentence, one more information is providing, that is that the gear F is fixed. That the gear F is fixed. Now if the gear F is fixed, this value here, it directly becomes 0. So NF becomes 0. So this data here is the given data, and this here is what we have to find. So let us proceed. So looking here, we can see that 3 of the speeds have been provided to us. So all the 3 speeds we can directly substitute here in the table, and we'll get 3 equations. So let us substitute. Ns means x plus y. So Ns is x plus y, and this has been told to be 500, positive 500. So this is our first equation. Then coming to NA is the arm. NA is the arm. You can see here NA is the arm. So NA, that is equal to y from equation point of view, and its value has been given as 100. So this is our equation number 2. Finally coming to NF. So this is a very long equation. NF equals y minus x times ts upon tf. So this is our equation number 3. So we'll have to solve as many variables as this from these equations. So using these 2 equations, you can see here y value is fixed, so that we need to substitute here, and we get the x value as 500 minus of y value, that is 100. So x value we get as 400. So x and y, both values we got here, and then we can substitute them both here in NF. And NF, we know it is equal to 0. Of course, it's equal to 0. So x, y, and NF both, all let us substitute here. So we get y value, that is 100, minus x value, that is 400. Ts upon tf, both values are not known, is equal to 0. Now we can take this equation further and get a relation between ts and tf. So 100 will be equal to 400 times ts upon tf. So the two zeros will cancel out, and we get tf equals 4 times ts. So this is a very important relation. Let's give it an equation number and keep it aside for use later. Now let's come back to the given data. The 3 values we have already used. You can see there are 2 values which we didn't use, and let us see what we can do with this. So here module is given to us and the diameter is given. Now if you remember, the formula for module is diameter by number of teeth. So this in this module and diameter is given, so we can find the number of teeth. So teeth will be equal to diameter by module. So this we'll have to do for f. So tf equals tf by m. Let us substitute those. So df value is 300 mm and the module here is 4 mm. So we get this as 75. Now let's use this equation here, and we get Ts will be equal to Tf by 4. So that will be 75 by 4. Wow. Now here there's a big problem. We cannot have fractional number of teeth. Fine. So number of teeth, they have to be always natural numbers. Fine. So we cannot have half a teeth or 1/4 of a teeth or something like that. So whatever values we get here, they have to be exactly divisible. We cannot have like this. This is not allowed. So what to do? Fine. So we'll have to take either the higher value of this or the lower one. Fine. Because this is not allowed. This value here that we got 75 is not allowed. We can either go for the higher value, which is divisible by 4, or the lower value. So if you go for the higher value, it's going to be 76. If you go for the lower one, it's going to be 72. 72 is much far off. So let us directly ignore this value. Let's directly ignore this value and let's go with 76. And then let us see what we get. So if we take 76 as the value of TF, then we get TS value as 76 by 4. And that will give us 19. 19 is what we got, the value of TS. So now we have found the number of teeth on F, we have found the number of teeth on S, and the number of teeth on the planet remains to be found. Once again, we'll have to take the relation between the diameters, convert it into the relation between the teeth, and that will allow us to find the number of teeth on planet. So here, this is the total diameter of the planet here, so dp. This here is half the diameter of the sun, so ds by 2, and this total length here is half the diameter of the wheel f. So this relation will give us df by 2 equals dp plus ds by 2. Now we can use the relation of module. Module equals diameter by number of teeth, so diameter will be equal to module into teeth. And since the module of all of them remain the same, it will get cancelled. And so let me just write the module here like this. Module of both these will come out common, number of teeth on planet plus number of teeth on sun by 2. So now the module will cancel out, giving us the relation between number of teeth. So now 2 of the teeth we have already found. Let us substitute them here in this equation and try to see if we get the number of teeth on P. So TP will be TF by 2 minus TS by 2. TF, it's an even number, so we can divide by 2, no problem. Okay, but TS comes out to be 19, and this as well is not to be allowed, because 19 by 2 we get a decimal point, so we cannot take 76 as well. So no 76. We'll have to go with the lower value in that case. So 72 is what we have to go with. So let us again redo all those calculations, taking 72 as the value. So TS, we cannot take 72. So 76 we cannot take. So we'll have to take that value as 72. Fine. So let's take 72 and see. So 72 by 4 gives us 18. Now 18 is an even number. Fine. So that is a safer value compared to 76. Now let us substitute them here. The TF value we considered 72. We considered 72 by 2 minus TS value we got 18. So 18 by 2. So this when you solve you get 45. So I guess we have found the number of teeth on all the gears. So TP value we have got as 45. TS value we got it as 18, and TF we got it as 72. Now the only one thing remains to be seen, that is the speed of P. If you see the speed of P formula, this is the formula which we'll have to use. So NP, okay, so NP equals y minus x times ts by tp. So y and x, both the values are known. Let us substitute them. Y value is 100 minus x value is 400 and ts value is 18. TP value is 45. Let us see what is the speed of NP. So this comes out to be minus 60. So minus 60 RPM is the speed of planetary gear P. Now some of you might say that the diameter was given to be 300 and based on that we got 75 teeth. And why didn't we go with 75 teeth? Fine. So is it correct? Are we allowed to make changes to the question itself? Well, to be fair, we cannot just decide the diameter of the gear first of all. Fine. So we'll just get some idea about what is the range of diameter, what is the approximate value of the diameter is what we can decide. But what's more important is the speed relations between them. Fine. So if you are given a chance to choose between either modifying the diameter or modifying the speed relations, the ratio of the speeds, then you should try to maintain the ratio between the speeds. Diameter, it can change. Slight variation in diameter will not cause much difference, but variation in the speed ratio will have a very adverse effect on the total design, whatever we are trying to achieve. And hence, that's the reason why we can make slight changes to the diameter. Fine. In fact, the diameter will come out to be slightly different compared to 300. So because we took 72 as the number of teeth, so 72 times 4, 288 mm is the exact diameter of the gear F. Fine. So we are not going with 300. We have to go with 288 mm diameter for the gear F for this epicyclic gear to maintain whatever speed ratios have been given to us in the question. So hope you have understood this problem. For more such problems, subscribe to our channel, hit like for this video if you really liked this video, of course, and don't forget to share it with your friends. Thank you for now.